Hello, this is video number 28 on my single variable calculus 2. In this video, we're going to talk about polar curves. Polar curves are curves that are easier to represent using polar coordinates. Here is an example. We want to find all numbers r and theta where r cosine of theta is root 3 and r sine of theta is -1. This allows us to consider the cases where r, the distance to the origin, which we assumed it is always positive, to be also negative. Let's solve this problem and I'll talk about that after this. So we want to solve this system of equations. We can solve for r from the first one, so that would be root 3 over cosine of theta. Then we're going to plug it into the second equation. We get root 3 over cosine of theta times sine of theta equals -1. So that gives us tan of theta equals -1 over root 3. So if tangent is -1 over root 3, it means it would have to be either here or here. So that's when tangent is -1 over root 3. Okay, so what angle gives you tangent of -1 over root 3? The angle that gives us tangent of -1 over root 3, which is negative root 3 over 3, is pi over 6, but negative of that. So it's actually something like this. So it's this angle. So it's either theta is negative pi over 3 plus 2 pi k, where k is an integer, or theta is this angle, which is negative pi over 6, or 5 pi over 6 plus 2 pi k. So theta is one of those two angles. Now let's take each one of them, plug it in, and then see what we get. So if theta is negative pi over 6 plus 2 pi k, we can plug it into the first equation. We get r times cosine of that. What is cosine of negative pi over 6? That is root 3 over 2. So that is equal to root 3. So that gives us r equals 2. Now if we take the other angle, theta equals 5 pi over 6 plus 2 pi k, and plug it into the equation, we get r times cosine of 5 pi over 6. Cosine of 5 pi over 6 is negative, so that's negative root 3 over 2. That is equal to root 3, so that gives us r equals -2. So the two solutions that we get are r equals 2, theta equals negative pi over 6 plus 2 pi k. This is one of them. Or r equals -2 and theta equals 5 pi over 6 plus 2 pi k. So what is the benefit of considering the ones on the right side, the ones that r is negative? That allows us to describe curves using nicer equations, and it allows us to create curves that are more continuous. So in other words, if you consider these two, you see that when you negate r, the angle is going to be changing by pi. So if you algebraically think about that one, if you add pi to theta and negate r, you get the same x and the same y coordinate. So in other words, geometrically what it means is if I have a point r comma theta and I reflect that about the origin, then what I get is negative r and theta. So negative r theta is the same as r theta, but just reflected about the origin. So considering that, we can draw some curves. But before we do that, let me do one more example and then we'll talk about drawing some curves. So if one polar coordinate of a point is r theta, then all of its polar coordinates are either r theta plus 2k pi or negative r theta plus pi plus 2 pi k. Find all polar coordinates of this point. So let's find out what the polar coordinates of this point is, what just one of them is, and then we'll find all of them. Well, if you look at this one, the x coordinate and the y coordinates are both -3. So r, which is the distance to the origin, is root 9 plus 9. So that is 3 root 2. And theta is this angle, which is pi plus pi over 4, because we have an isosceles right triangle here. which is 5 pi over 4. So all of its polar coordinates are going to be 3 root 2 5 pi over 4 plus 2 pi k, or minus 3 root 2, and then we have to subtract pi from that. We get pi over 4 plus 2 pi k, and of course k is an integer. So these are going to be all of the possible polar coordinates of this given point, -3, -3. So -3, -3 are the coordinates of this point in the Cartesian coordinate system. Okay, so let's look at a few examples on sketching graphs. So let's sketch each of the following polar curves. So let's first look at the curve r equals 1 plus cosine of theta. So here's how we draw these types of curves. What we do is we draw the behavior of r in terms of theta on one coordinate system, and then we take that and translate it on the xy plane. So as we see, this is 1 plus cosine, so the maximum is at theta equals 0, which we get 2. Then it comes down, and then it goes back up. And at 2 pi, it goes back up to 2 again, so at 2 pi. At pi, we get 1 plus -1, which is 0. At pi over 2, we get 1, and we also get 1 at 3 pi over 2. So we take this and we put that on the xy plane. Let's see what happens on the xy plane. So let's start with this piece of the curve on the our theta plane and put it on the xy plane. So if we put that piece, well, the initial point is theta equals 0. So this point is theta equals 0 and r equals 2. So that's a point of distance 2 from the origin with angle theta equals 0. This point here is theta equals pi over 2 and r equals 1. So it goes to this point right here. And from the first point to the second point, r is decreasing. So that means it gets closer to the origin. So it's something like this. The next portion still r decreases and it gets to theta equals pi and r equals 0. Well, theta equals pi, r equals 0 means we are at the origin and theta goes from pi over 2 to pi. So we get a shape like this. Now we continue with the next portion. So next portion is right here. So we get to theta equals 3 pi over 2 and r equals 1. So we get to a point like that here. So it's a very similar curve, except it is just reflected about the x-axis. And the last piece is the same. And once we go beyond 2 pi, the curve is repeated. This curve is actually called a cardioid. So that's the first one. Let's look at the second curve. The second curve is 4 plus 3 cosine of theta. Okay, so this has a similar shape, but not quite the same. So 3 plus, so this is r equals 4 plus 3 cosine of theta. We'll do the same, we'll use the same strategy. So we have the maximum 7, it goes down, it doesn't get to the x-axis, theta axis, the horizontal axis. It gets down to 4 minus 3, which is 1 at pi. At pi, it gets to 1. Then it goes back up, and at 2 pi, we get to 7 again. We'll take this curve and we are going to draw that on the xy plane. So this is 4. So when theta is pi over 2, we get cosine of pi over 2, which is 0. 3 times 0 plus 4, so we get 4. And then at 3 pi over 2, we get the same thing as well. So we'll take this piece and draw that here. So this is the x-axis, the y-axis. We'll draw that piece here. So theta is 0. and r is 7, so that's the first point. Then the next point right here is theta equals pi over 2 and r is 4, so it is right here. So we have a shape like that here, and then it goes all the way to theta equals pi and r equals 1, so it gets to this point right here. And from that to the last point here, theta, the curve gets closer and closer to the origin, so we get a shape like this. And then we have something very similar at the bottom as well. So this is quite similar to cardioid, but it's not quite the same. The slope at -1 is slightly different than the other one. So it's not quite tangent at -1. So this is actually a different kind of curve. So this is called a limacon. Now, those two are actually the easier ones. These two that I'm going to draw are going to be a little bit more difficult because in these cases, r becomes negative. So again, we are going to draw this. R equals, so this is A. The first one is r equals 2 cosine of 3 theta. So we're going to start drawing this on the r theta plane, and then we repeat the same thing. We kind of like trace it on the xy plane. So the actual answers are on the right side. The left side is a way to understand what the graph is going to have to look like. Okay, so let's graph this curve on the r theta plane, and then we'll put it on the xy plane. Okay, so at theta equals 0, we get 2, and it goes down, and then it gets to theta r equals -2. So at pi over 6, it gets to 0. At pi over 3, it gets to -2. Then it comes back up at pi over, so it is 3 pi over 6, which is pi over 2. And then it goes back up, so that's 4 pi over 6, 2 pi over 3, and then it goes back down. So again, we have 5 pi over 6 goes down to pi. It gets to pi at this point, and then goes back up again. So it becomes 7 pi over 6, etc. So it continues this way. And then we get to the next one is, so the next one is 8 pi over 6, etc. So I'm not going to draw the whole thing, but we'll see what happens. So if you look at the first part, it starts from here. So the distance to the origin is 2, and angle is theta equals 0. Then at theta equals pi over 6, it gets to the origin. And between these two, r gets closer and closer to 0. To this is theta equals pi over 6. So that's this piece of the curve. The next piece, which I'm going to mark by blue, is going to be from pi over 6 to pi over 3. So it's here. But in this case, r is negative. If r were positive, then it would start from this point, from the origin, and it would go all the way to r equals -2. So it would have been something like this if r were to be positive. It would start from the origin, it would go to theta equals pi over 3 and r equals 2 if it were positive. Now that it is negative, it will be reflected about the origin. So I'll have to take the same thing and I'll have to reflect this about the origin. So it's something like this. And by the way, this portion is not part of the graph. So it is something like this. Then the next portion is this portion. So again, r is negative, and theta goes from pi over 3 to pi over 2. If r were positive, it would start from here and it would come to the origin. Now that it is negative, it would have to be like this. It would be just a reflection of the same thing about the origin. So that's the next portion of the curve. Let's look at the next portion of this. The next portion is the positive portion. So we start from pi over 2 and 0. 0 is r and theta is pi over 2. And we go all the way to 2 pi over 3. So we'll have to break this up into 3 pieces again. This will end at 2 pi over 3. We start from the origin and it is supposed to end at 2 pi over 3. So if I start from here and end at 2 pi over 3, it would be something like this. And this angle is, by the way, pi over 6. And then the next portion would be from, so this one is 5 pi over 6 as we see in this diagram, and then it goes to the origin. So it starts from here and it gets to the origin. Now if you look at the next piece, this piece right here, we start from the origin and we end at this point, which is r equals -2 and theta equals pi. 2 pi would be here, so -2 pi is right here. And angle starts from 5 pi over 6 and it goes all the way to pi. So it is like this. So this is what we get. And after that point, it is going to be repeated, because after that point, what happens is we start with r equals cosine of 3 theta. If we increase theta by pi, we would get cosine of 3 theta plus pi, which is cosine of 3 theta plus 3 pi, which is negative cosine of 3 theta. And negative cosine of 3 theta is exactly negative r. So if I replace theta by theta plus pi, I would get negative r, which would be the exact points, because we know that if we negate r and add pi to theta, we get the same point. So this would be the curve. So this is a rose, this is a 3-leaf rose, and the distance from the origin to the farthest points are 2. So let's look at the next example. So the next example is sine of 2 theta. Okay, let's see how we can get sine of 2 theta. Well, sine of 2 theta starts from the origin and it goes up and down. So we have pi over 4, pi over 2, 3 pi over 4, and pi, and then it repeats after that as well. So I have to draw up to 2 pi, but let's first draw these pieces on the xy plane and then we'll get to the rest if needed. Okay, so let's look at the xy plane. Well, let's look at the first piece. The first piece starts from the origin because both r and theta are 0. When r is 0, it's the origin. The angles increases from 0 to pi over 4. So it is here. And also the distance is at most 1. So it increases to 1. So it starts from here and it goes all the way to 1. So let me just make that a little bit more closer to the angle bisector. So this is what we get, is pi over 4. Then it goes back to the origin. So if you look at the next piece looks like this. Then we can look at this bottom portion. The bottom portion starts from the origin and it ends at r equals -1 and theta equals 3 pi over 4. So 3 pi over 4 is here and r equals -1 would mean it would be on the other side, because 3 pi over 4, 1 is on this side, but 3 pi over 4, -1 would have to be on the other side. So it would be like right here. So we would start from here because theta is pi over 2. And if it were positive, it would look like this. Now that it is negative, it would look like this. So we get that. And then after that, we'll start from 3 pi over 4 and goes back to the origin again. So again, with negative sign, it would be, without negative sign, it would be on this side. With negative sign, it would be on this side. So this is what we get. Now let's look at the remaining portion. The remaining portion starts adding pi. So if you add pi, we have r equals sine of 2 theta. If we add pi, sine of 2 theta plus pi, this is the same as sine of 2 theta, which is the same as r. So that means I have the same curve but reflected about the origin, because if r theta is a point, then we also just showed that r theta plus pi is also a point on the curve. So that means we have the same curve reflected about the origin. So we get, and this is the portion from pi to 2 pi. So we get a 4-leaf rose. So these examples are examples of roses. Okay, let's look at the next example. So we want to sketch the polar curve given by this. So we're going to now draw this curve. R squared is equal to 4 cosine of 2 theta. For this one, notice that this would have to be positive. So what does that mean? It means 2 theta would have to be in the first or fourth quadrant. So it cannot be in the second quadrant or the third quadrant, because in those quadrants we have negative values for cosine. So now, if you look at cosine of 2 theta, maybe you don't know exactly what the graph of the square root of cosine of 2 theta looks like, but we know roughly that it would be decreasing in the first quadrant and then increasing in the fourth quadrant. So we can start graphing this one on the xy plane. So what do we know? We know that 2 theta is in the first quadrant, so it would be in this range. So theta is between 0 and pi over 4. So this is the first part. And if you look at cosine, starts from here. So r is equal to 2. When theta is 0, r is 2 or negative 2. So for negative 2, we have the same thing on the other side, because the distance is 2 and theta is 0. But if your distance is like negative 2, it would be on the other side. And then we go all the way to pi over 4. So it looks like this. And then if you look at the other side, 2 theta between 3 pi over 2 and 2 pi, that would mean theta is between 3 pi over 4 and pi. And by the way, for the reason that we just mentioned, that if r theta is a solution, then negative r theta is also a solution, because this gives us r equals plus or minus 2 cosine of 2 theta in square root. That means we can reflect it about the origin, and we get this portion as part of the solution, part of the curve as well. And if you look at the region, the theta between 3 pi over 4 and pi, we have this one. We have a very similar graph on the other side as well. When theta is pi, we get cosine of 2 pi, so we get this point. So we are going to have a curve like this. And on the other side, we have the reflection as well. And once we get to that, it just repeats itself. Let's look at a couple more examples. Sketch the two polar curves given below. So the first one is r equals 3 sine of theta. So the best way of drawing this one is to turn it into Cartesian. Remember that we can find sine of theta in the formula for y. Y is r sine of theta. So that tells you that sine of theta is equal to y over r. Taking that and plugging into the equation, we get 3y over r, which means r squared is equal to 3y, which means x squared plus y squared is equal to 3y. So that gives us x squared plus y squared minus 3y equals 0. So x squared plus y, if we complete this square, we get y minus 3 halves squared equals 9 over 4. So this is a circle centered at 0, 3 halves with radius 3 halves. So this is the curve that we just saw. So this would be the curve. This is in fact a circle. The next one is r equals 4 cosine. So r equals 4 cosine of theta. We know that cosine of theta appears in the formula for x. We have x equals r cosine of theta. So if we take that and plug it into here, we get r equals 4 times cosine, which is x over r. So this gives us r squared equals 4x, which is to say x squared plus y squared minus 4x equals 0. Completing the square, we get x minus 2 squared plus y squared equals 4. So this is a circle of radius 2 centered at 2, 0. So if we were to graph this one, the center would be 2, 0, and the radius would be 2. So this is our curve. Okay, so one last example. Sketch the polar curve r equals e to the power of theta. Okay, so let's look at the graph of r in terms of theta, and then we will draw it in the xy plane. Well, this is an exponential graph, and they said r is greater than or equal to 0. So it starts from 1 and it's exponential. So it goes to infinity very rapidly. So what happens on the xy plane? Well, on the xy plane, it starts from the point 1 comma 0, because for theta equals 0, r is 1. So it starts from that point. And then the radius gets rapidly large, which means it gets away from the origin. So what is this curve? Well, this is a spiral. Okay, so to summarize, we learned that if we want to look at negative r theta, that is the reflection of r theta about the origin. To sketch a polar curve, draw the curve in the r theta plane to understand how r changes as theta changes. Based on that, trace the graph on the xy plane. You need to know how to graph circles, which are r equals a cosine, r equals a sine of theta, where a is a constant. Cardioids, which are the curves of the form r equals a plus a cosine of theta or a plus a sine of theta. Limacons, which are the curves of the form r equals a plus b cosine of theta and r equals a plus b sine of theta. And in this case, a and b are not the same, and they are also not negative of each other. We need to know how to graph roses, which are r equals a cosine of n theta and r equals a sine of n theta. N is an integer and a is a constant. And you also need to know how to graph lemniscates, which are the curves of the form r squared equals a squared cosine of 2 theta, then a is a positive integer. And you also need to know how to graph spirals. Those are curves of the form r equals a to the theta or r equals a times theta. Both of these are spirals. This one spirals much faster because it is exponential. And I gave you examples of all of these. And that brings me to the end of this video. I will see you in the next video.